Hello and welcome back to the course. Now we are going to study about the ElGamal algorithm. Okay, so let's begin with the ElGamal algorithm is basically the public key crypto systems. That actually, when we say there is a public key and private key being used for the encryption and decryption process in the, various types of algorithms. So ElGamal is one of the algorithm in which we are going to use it the public key. Okay, and now the specialty for this is it is a asymmetric key encryption process, which the ElGamal algorithm it uses the asymmetric key encryption for the communicating between the two parties and encrypting the message. So as far as this particular crypto system is concerned, it is based on the difficulty finding the discrete algorithm in a cyclic group. That is, even if we know g raised to a and g raised to k, it is extremely difficult to find out the g raised to ak. Now, as g raised to k, as we all of you know that g is a sequence number which is encrypted one. We are going to see the example of this. Okay, now Algama algorithm. Suppose we are going to take a same example between the communication between the Bob and Alice. Suppose Alice wants to communicate with Bob, and it will go with the various steps. So first step is Bob generates the public and private key. Then Bob chooses a very large number q and a cyclic group f of q. From the cyclic group f of q, he chooses any element g and then element a such that GCD is equal to 1. Then he computes h is equal to g raised to a. Bob publishes the f h is equal to g raised to a, q and g as his public key. Okay, q and g as his public key and retains a as a private key. So there are three parameters q, g and a. So q and g are specifically dedicated for the public key and a for the private key. Second step is Alice encrypts the data using the Bob's public key. Okay, so then Alice selects an element k from the cyclic group of f of f such that the GCD kq is equal to 1. Then she computes a p is equal to g raised to k and s is equal to h raised to k, which is equivalent to the g raised to ak. Okay, then she multiplies s with the m. Then she sends the p ms is equal to g raised to k ms. Okay, so this is a message that we are going to send. At the reverse side, that Bob decrypts the message. Okay, then Bob calculates s dash. Okay, s dash is equal to p raised to a and g raised to ak. Okay, then received message. Then he divides the m into s by s dash to obtain m as s is equal to s dash. Okay, so there is an example for this ElGamal encryption algorithm. We will have a look on that. Now, this is a Python code. A random function is being imported and based on the a value, because a need to declare first with this function. Okay, now we are going to define the GCD, then generating the large number random numbers, right? Then defining the general key that we are going to have the length, because key length is need to be defined over here, right? So with power levels, and then we are going to have this modular exponentiation in which we are going to define the power levels in terms of components like a, b and c. Okay, so now here x is initiated to 1 and y is initiated to b. So with the help of this while loop, we are going to have the calculation of the b. So in this way, we are going to get the b from this loop. Next step is asymmetric encryption, in which we are going to define the encryption components msg, q, h, and g. Now here we are going to get the decryption. Again, we are going to define the components same way. The dr message empty set was defined earlier. Here the en message is there. Okay, so we are going to have the define the empty set. Later on, we are going to have the return values one by one after executing this for loop. Okay, then driver code, which is a main code. Here in this case, the message is encryption, so we have to convert it into the numerical form and then we have to transfer. For that purpose, q length is used, right, which is again a random number and which is defining with the help of the powers. Okay, now this is a length which is defined. Then g is also defined. Okay, and then key is used. Key is private key obviously, and for the receiver. Okay, now h is defined in terms of the g, key and q. Now this messages that we are going to have is with the g raised to a, g raised to k, and this kind of things are there with the numerical values, not with the actual encryption message. Okay, so message, original message. Now here the sample output that we're going to get is the original message is encryption, and while processing from encryption to decryption, we are going to have this g value as 49 digits. Okay, 49 digits are there. So same length are being maintained for 0 to k, 0 to a, 0 to ak likewise. Okay, and the decryption message that we are going to get is encryption. That means before encryption, the message is in this character, which is the spelling of its this one encryption, and while processing, it is in the numerical form. So this is a specialty for the ElGamal algorithm, which transfer the message in terms of the numerical form, not with the character form. Okay, so this is one of the example that we can have. Next is this crypto system in which we are going to have the original message m is masked by the multiplying g raised to ak to it. Okay, then to remove the mask, the clue is given in the form of g raised to k. So unless someone knows a, we will not be able to retrieve the message m. Okay, so this is because of finding the discrete log in an cyclic group, which is difficult, and simplifying the knowing g raised to k and g raised to k is not good enough to compute g raised to ak. So this is my reference for this particular presentation. Okay, hope you understood. Thanks for watching.